In this video, we'll talk about the bell work called calculating the MAD. MAD stands for mean absolute deviation. And as we go through the steps, I think you'll see what that actually means. It's a process. You may work with a partner and share your data and calculations on this exercise. Everybody has to turn in their own paper, however. And here's the data. A teacher asked a class of 30 students to measure the diameter of a tennis ball in centimeters. The class measured 2 brands, Spalding and Penn, and a dot plot of the data is below. So the first thing we're asked to do is to fill in the data table. So we need to find we're going to need to find the mean of the data in order to solve this. So I'm going to use a spreadsheet to do that. I think that's the easiest way to go. So I'm going to switch over to Google Sheets. I'm going to create a new document. I'll call it MAD. And I'm going to enter the data. So these are all numbers, so we'll start with 63. It's helpful if somebody reads it to you. Let's see, how many 65s? 1, 2, 3, 4, 5, 6. One, two, three, four 66s. 2 67s. All right, there's another column of data for the Penn tennis balls. And then 65 shows up 1, 2, 3, 4 times. Oops, and I missed one on the left here. There's one more 67 on the left. Okay, so there's all my data. Now, one little reminder here. If you select the data, at the bottom, it tells you the average. The average is 65.375. And it also tells us the sum is 1,046. So back in my data here, I'm going to put 65.375, and my sum was 1,046. Okay, now I need to find the deviations. Now, the definition of the deviation is each value minus the mean. So that the first one would be 63 minus 65.375. But I don't want to do that by hand. I think that's too tedious. So what I'm going to do is use a spreadsheet to do it. I'm going to put it in column C. I'm going to type in equals A1 minus 65.375. And then I'm going to fill down those numbers. So there are all my deviations. And it's going to ask me to do the same thing with the next set of data. So if I look at the next set of data, I can see that the sum is 971 and the average is 64.733. I already forgot what the number was. 64.733. So I would do the same thing here. I would take each value, start with the first value, 62, and subtract that mean, which is 64.733. But I'm just going to go ahead and do this in my spreadsheet because it's so much faster. So I'm going to type in my formula. My formula is This time I'm taking B2, or excuse me, B1 minus 64.733. And then I'm going to fill that down. And I can see, this is kind of interesting, down in the corner, it gives me the sum of those values. I can do the sum of these values as well. So the sum is approximately 0 for both. The sum is basically 0. And that's what we saw when we did this activity the first time in class. So I'm going to write this down now. So I'm going to cheat a little bit. Maybe not cheat. I'm just going to skip a step. I'm going to say that this is on my spreadsheet. Now, if you write this, that's fine with me. If you say that's on your spreadsheet, but please be prepared to show me your spreadsheet. So don't lose it or erase it. Hang on to it so we can see it. Okay, so I think we're ready to answer some questions now. The centers of the dot plots. So for Spalding, the center was at 65.375. So the center is a little bit greater than 65. And for Penn, it was at 64.7, so that average was a little bit lower. Okay, so I've marked the means. I'm going to compare the centers. I'm going to say the average diameter for Penn is smaller than that for Spalding. And then whenever I write an answer to compare two values, I want to give the numbers. So I will say, I kind of didn't leave myself a bunch of room. I'll put it here. So 64.733 versus 65.375. The spreads. Remember, the spread is the max minus the min. So for Spalding, the max is 67. The min is 63. So the range is going to be 4. 67 minus 63 is 4. What about for Penn? It goes down to 62. So the range is going to be 67 minus 62, or 5. So again, I would say the spread for Penn, which is 5, is greater than that for Spalding. So when we compare, when we look at the word compare, we want to say greater than, or less than, or equal to. That's how we compare numbers, with greater than, less than, or equal to. Question 7 asks us to compare the shapes of the dot plots. I like to kind of sketch on here. I feel like that has a bit of a tail, and this one has 2 bumps. When we have a tail, it's skewed. When we have 2 bumps, it's called bimodal. So we would say Spalding data is slightly skewed left. Penn data is bimodal. And again, that bimodal means that it's got 2 peaks. Okay, finally, what can we say about the sum of the deviations? Well, we had already done that. Let me go back to my spreadsheet. When I look at the deviations and I look at the sum, which again is found in this lower left corner down here. Oops, let me go back. Done. Oops. There I am. So when I go, what the sum is in that lower left, and you can see the sum is 0. And that's what's supposed to happen, because that sum indicates that the data is balanced. Oops, forgot to switch back. It is 0. All right, that concludes the bell work.